So starting with number 1 from the 7.1 assignment, we want to look and see that we can set up the hypothesis test correctly. And referring back to this table in the book can help you get the right symbols to go with the right words. Now for this example, the mean life of the battery for a certain type of laptop is more than 8 hours. So more than something would be greater than. And so that doesn't have an equal sign in it, so that has to be your alternative, which then means your null would be less than or equal to. And this is our claim. That's what the person's claiming. So when you're asking about which of the hypothesis tests are the claim, it's dependent upon the problem. And it's definitely the alternative in this case, because that matches the claim that the mean is more than 8 hours. Number 2, I'm just basically working with definitions here. We always have two tests, the null and the alternative, and they're complements of each other, which means everything is covered between the two of them. If one is greater than or equal to, the other one is less than. So every number is covered between each other. They're each other's complement. And there's always two decisions that we can end up making. One is to fail to reject the null hypothesis, and that's if your sample would come back really close to the null hypothesis. And the other one is reject the null hypothesis. And that is if your sample comes way far out in the tails and it's very unlikely. So those are the only two decisions that we ever make in a hypothesis test. 4 just kind of builds off of what I've already covered in this video. The null hypothesis always has to be the claim that has the equality in it. So 5 and 6 were similar to 4. Number 7, anytime your alternative is less than, we're doing a left tail test. Greater than is a right tail test, and if it's not equal to, that's when you do a two tail test. And just to visualize that, if you're looking for something less than a certain mean, less than a certain value, you're going to the left. That's why less than is left tailed. Greater than a certain value, you go to the right, and that's why it's right tail for greater than. And then the problems up through 12 deal with what we just have already talked about. So looking at number 13, we start talking about type 1 and type 2 errors. So here's the definition. A type 1 error occurs if the null hypothesis is rejected when it is true. So that's a mistake. It's an error because we're rejecting something that's true. A type 2 error occurs if the null hypothesis is not rejected when it is false. So again, that's a mistake because we're not rejecting it, but it was false, so we should. One thing to point out is we never know if we're making an error because it's a mistake. It's an error. So let me show you a visual. Going back to this diagram, if we had the null hypothesis was that the mean was equal to 20, the alternative is the mean's greater than 20. If our sample came way back out here, way far in the right-hand tail, we would reject the null because this is a very unusual sample, and we would assume that the alternative is true because this is much more likely that if the mean's greater than 20, a sample way out here actually is close to that mean that's greater than 20. That's what you'd expect. So we're rejecting the null. But there are cases. I mean, way out here in the tail still happens 5% of the time, a certain percentage of the time. So sometimes you will get a sample way out here and makes you reject the null because it's so unusual, and you assume the alternative is true. But sometimes that's a mistake. You don't know you're making it. Your null is actually true. You just had a very unusual sample for some reason. And so that's a type 1 error because you're rejecting the null when in fact it is true. And then a type 2 error is kind of the opposite. It's if we got one of these samples really close to 20, and so we say there's no reason to reject the null. We didn't get back an unusual sample, but in fact the mean really is some value greater than 20. And so the sample we got back made us reach the wrong conclusion because we did not reject the null, but in fact the null was false and we should have rejected it. And so for these problems, like number 13 here, it's helpful to start off by writing down what your null and alternative are. So for example, a lumber store claims that at least 60% of its new customers will return to buy their next order of lumber. Well, your null hypothesis at least 60 is a greater than or equal to 60. So that has the equal in it. So your null would then be that the proportion is greater than or equal to 60. Your alternative then would just be the strictly less than 60, the less than sign. So a type 1 error is rejecting a true null. And a type 2 error is failing to reject the null when you should have. So a type 2 error will occur when the actual proportion of customers who return to buy their next order is less than 60, but you fail to reject it. For whatever reason, you gather a sample. The sample doesn't make you want to reject it because of where it fell in the distribution. You didn't think you should reject it. And so based off that sample, you make an error and fail to reject it when in fact, in reality, the proportion who come back is less than 60. So for 14, again, you have to try to explain and define what a type 1 and type 2 error will be. Remember those definitions. Same with 15. And so the rest of the problems kind of all deal with these definitions we've gone over. If you have questions about any of them, let me know. Reach out. Going up through 21 here, I'll walk through this final one. So looking at 21, a researcher claims that the standard deviation of the life of a certain type of lawnmower is at most 3.1 years. So at most a value would be this situation where we have a standard deviation is less than or equal to 3.1. So it's at most 3.1. Our null hypothesis would be the standard deviation is less than or equal to 3.1. Our alternative would be that the standard deviation is greater than 3.1. So at most 3.1, 3.1 or less, that contains the equality in there, which means that's part of the null hypothesis like I just went through. So how should you interpret a decision that rejects the null hypothesis? Well, if we get back a sample, it causes us to reject it and assume that the alternative is true, that it's greater than 3.1. We'll say there is sufficient evidence to reject the claim that was made that the standard deviation of that lawnmowers is at most 3.1. How should you interpret a decision that fails to reject the null? So failing to reject, what you would say there is just that there is insufficient evidence to reject. We haven't proved anything. We just don't have enough evidence to reject the claim that was stated in the null hypothesis.